welcome everybody to the Nomad 0.10 webinar. Ed already introduced me, Eric Veld, developer advocate, so can skip this one and we have more time for the demos, which is always good. So let's quickly go through the agenda. So first we're going to talk about the new features in 0.10. I'll quickly go through some of them. And then we're going to dive deeper into the network namespaces feature and the Consul Connect integration, which heavily relies on the network namespacing. And then we're going to finish up with questions. If at any time during my demos you see something and you would like to see some more code or something, please let me know in the questions, and then I can always go back into the code and show you. All right. So are the slides also moving? Because last time I had issues with that. Double checking with that.
The slides are moving.
Okay, cool. All right, so let's start with the new features of Nomad. First of all, host volumes is new, and this allows you to mount paths from your host machines, so your client nodes, into your allocations. All right, so how you would do that is you would define in your client configuration a host volume. Say, for instance, in this case, we're defining a volume called MySQL, and we are allocating the path up to MySQL data to that host volume, and we are specifying that we want it to not be read-only, right? So we can either choose to share a path on our host system as read-only, or where the allocations can also write. And then these volumes we can actually use in our jobs. So we can use them in multiple jobs. In this case, we can define a volume for this group for the MySQL server, where we specify that it's type host. Later, there will be more types when the CSI driver is implemented. And in this case, we're pointing at the host volume called MySQL that we defined before. And we've specified that we want to be able to write to that volume. And then we can use that volume in multiple tasks by mounting it there. So again, we create a volume mount that points at that volume we just defined, and we specify where we would like to mount that into our allocation. And again, we want to specify that we want to be able to write to it. So if you would use this volume in multiple tasks, you could, for instance, have one task that writes to the volume and have other tasks that read from it, or even entirely different groups that use the same host volume, but mounted in a different allocation. So another very nice feature that was introduced is the Allocation File Explorer, which allows you to browse files in the Nomad UI. So where you would normally have to exec into an allocation and then check out the files or use the fs command of an allocation to browse files, you can now do that directly from the Nomad UI. So if you want to see if a configuration file that you are rendering from a template in your Nomad job is actually rendered correctly, you can now easily do that by browsing to the allocation and then just looking at the files. And this also includes rich media files. So if you have an image inside your allocation, you can even look at those just from inside the Nomad UI. Then one of the big ones, network namespacing. So network namespacing allows you to define shared networking, and that networking is then shared amongst tasks inside an allocation. Before, you could also, for instance, use the Connect integration by doing it manually by, for instance, specifying separate tasks for an Envoy sidecar and then using another task to register that service. And you would have these sidecars, but there wouldn't be isolation of these groups. So if you would have a service and you would only want it to be exposed through a sidecar proxy, you would not be able to do that because you could just circumvent that proxy and then talk to the service directly instead, right? So it was connected to the service mesh, but security-wise, it didn't have the benefits of the isolation. So by specifying the network namespacing and using the bridge networking, each of these groups now gets its own IP address and is isolated from all the other groups. But the tasks inside this group still can reach each other without any problems. And then if you would want to, you can still expose ports from one of those groups to the host system if you really wanted to. So there's multiple network modes that are supported. So one of the most interesting ones is the bridge networking. So you get the shared network stack and you get a virtual network device inside that group. And then the NAT rules are actually applied where you can have ingress and egress inside that group. The host mode is pretty much what you had before the 0.10 features were introduced. So that's basically the old way of mapping the networking, where everything gets mapped onto the host networking. And then finally, also an interesting one is the network mode of none, where you do get the shared networking stack within that group, but there's no ingress and egress, so it's totally isolated. So how would we start using this? So there is the network stanza, and you might have seen the network stanza before, but it was located in the resources block of your tasks, where you would specify the speed of the network and you would specify the ports that you would want to open up for that task. Now you can define a network block on the group level, and you can set the mode of that network. So in this case, we set the mode to bridge. And then if we would like to map ports the way we would do that before, say for instance, you had a Docker container where you had a port map to map a port of your network into that container. Now you can just specify the port on the network, specify the static port on the host, and then the two which of the group ports you want to map it to. And you don't have to worry anymore about the port mapping of, say, for instance, a Docker port. You can do it just through this, and then Nomad will actually hook that up for you. And if you still wanted to use the old way of doing things, you could specify the mode of host, which would basically give you the same networking as Nomad 0.9. And the cool thing is, you can actually mix and match drivers within the group, and they will all share that same networking. So if you have a group with a task that uses the exec driver and another one that uses the Docker driver, they can just talk to each other as if it is a flat network, and you don't have to worry about any of the port mapping. So this works for all of the drivers that support the network modes. Okay, so let's start using this a little bit, right? So I have a demo setup where I have 3 Nomad clients, 1 Nomad server, no jobs running, and I have a Consul server already running with Consul agents on all of the Nomad nodes. And I've actually created a setup where everything you can run locally and runs within Docker Compose. So you can take this Git repo later and try it out for yourself. So instead of having VMs, we just have a fat container with several processes in there managed by supervisor D. So as if it was a VM with systemd, we have a Nomad process running, we have a Consul process running, and then there's a Docker daemon on there. And then this is just a little hack because I'm on Windows WSL2, so you can ignore that. And then we have the multiple machines. So just see these as VMs. So we have a Consul machine that is connected to the internal network, and it has 8500 exposed on the local machine, so I can actually show you the UI, and it's running as a server only. Then we have a Nomad server, and we have 3 Nomad clients, so Nomad client A, B, and C, right? So that's what we have running right now, but what we want to do is we want to deploy an application on there that we can use the networking on. So let's jump to our first job, and we're gonna do API where we're gonna define bridge networking. So as you can see, I've defined the network block on the group level, and I've set the mode to bridge. And then other than that, it's just a service that uses the Docker driver, and basically it listens on an address and then responds. So this is a service created by a colleague of mine, Nick Jackson. I can link to it later if you're interested in using this for your own demos. So let's spin this up. So to prevent any typos, I've actually made a makefile that'll go through the steps for me, but I'll actually run you through all of them, right? So I'm just calling nomad run and then passing in that job file I just showed you, right? So if we take a look at nomad, we now have the job running and the allocation has been placed. And if we look at it, we don't see any networking addresses being exposed. Okay, so what does that mean for our allocation? Well, let's take a look at the machine it's placed on, and let's figure out what the IP is of that one. So if we take a look at that machine, we see that it is 0.10, right? So if we do a curl to that address, and my application is running on port 9090, so let's see if we can reach that. Okay, we are refused, so it's not bound on the outside of that machine. Let's see if we can go inside that machine, right? And try and do a curl on localhost, because see if it's exposed there. Okay, so it's also not listening there. Is the application actually working? Well, let's double check that. Okay, let's add curl quickly. Okay, so the application is actually running and it's listening on localhost 9090, but we're not exposing it to the host machine. All the other tasks in the task group would be able to reach it, but the host cannot. So let's try and add the actual host routing to that by adding a port for HTTP that will forward port 9090 on the host to 9090 in the task, and see if that will improve things for us. All right, so let's go back here. So that would be step 3. Okay, so if we look at the jobs, we see API is still running. And if we look at our allocation, we now see that we have a host address allocated to us. So it's moved machine, so it's now on 0.11. But if we now curl that, we can actually now reach it from the outside. So that's cool. Now, say for instance, this was an API gateway or something that we do want to expose on a certain IP, then we can do that this way. But just to verify things, let's take a look on the machine. All right. Okay. So localhost 9090 still works, but if we take a look at the listening ports, we don't see 9090 listed here. And that's because we don't actually create a listener on the host. Nomad will actually use the CNI drivers to configure IP tables, in this case for the bridge networking, to actually forward the traffic to the correct ports in the correct allocation, right? Okay, so now that we have the networking specified and that's all working, let's move on to the next big thing. So Consul Connect integration. Well, let's first step back, and for the people that joined us that might not know Connect or Service Mesh, let's just do a quick overview of what that is, right? So a service mesh consists of 2 parts. First of all, you have the control plane, which is responsible for the service catalog and things such as authentication, and it's also responsible for configuring the data plane. And the data plane consists of these co-located proxies, and they get co-located with your services, and they are responsible for actually routing the traffic between your services. So actually making sure that the packets from app A end up at app B. So how does this work in detail? So we have the console server, which is the control plane, and on each of the machines we have the console clients. And then the console client will actually start up the sidecar proxy for us and configure it. But to do that, we must first register our service. So we're registering the service web, and to the normal service registration, we're going to add some additional stanza, so the connect stanza, and we're going to configure our sidecar proxy. So in this case, web wants to talk to a service called MySQL, so it wants to talk to a database, and it wants to do that on the local bind port of 8001, right? So we register this in console, and then we give the console client the command to start up the sidecar proxy. It will then start the Envoy proxy and configure it with the local listeners so that when we try and reach MySQL on localhost 8001, we actually get forwarded to the sidecar proxy that gets co-located with the MySQL service itself. So how that then works is we have our sidecar proxies. On the left, we have the proxy for web, and on the right, the proxy for database. So when the proxy for web gets started, it knows that it has an upstream of MySQL. So it wants to know, okay, where is this database located? From the service discovery inside console, it then gets the address and the ports, just like you would have with traditional service discovery. And then it knows how to reach the sidecar proxy of database. So services don't talk to each other directly anymore. They go through these sidecar proxies. But then you might think like, okay, so then instead of circumventing my services like before, where I could just go past the sidecar proxy and talk immediately to the service, I could now just talk through these proxies and reach whichever proxy I wanted. And then what do we reach with that? Well, if we move from host-based security towards service-based security, where we don't trust any of the machines anymore, and we only trust services themselves and their identity that was given to them, we can then lock things down in a different way. We can then do things such as create rules that say, for instance, deny traffic from star wildcard. So basically everything, right? Wildcard to wildcard, all the traffic gets denied, and then we can specifically open up the traffic to allow traffic from, say, for instance, web to app or web to database, right? And then instead of having to define firewall rules that says, oh, traffic from this machine to that machine is allowed only on this port, we can just do that on a service level. If you're using things such as a scheduler like Nomad, applications can get moved around. We just saw that our application was first running on .10, and now suddenly it's running on .11, the IP address. So then we would have to add that machine as well to our firewall. And then there's multiple applications running on there. So we need to open up all those ports for all those IPs as well. So what we usually end up doing is you have a wall around your castle, but then you're lowering the bridge and just say, okay, everything can come in because we trust our local network, our internal network. But is that still the case when you're moving to cloud, where you're running on shared hardware? Like, it's better to just assume that everything is unsafe and only open up specific services to service communication. So if we've defined these intentions, what will then happen when web tries to talk to database? It talks to its local proxy, which knows where to find the database proxy, and it'll try to instantiate a TLS handshake. And what the other side will then do is it'll check, like, is web allowed to talk to my service database? Yes, okay, then the TLS connection gets established, and then traffic can flow from web to its proxy, from that proxy to the other proxy, and then to database. And this interaction only happens on the establishment of the connections, so the overhead is actually very minimal. Okay, so now that we know what a service mesh is and how the sidecars work, how can we start using this in our Nomad jobs? So you might have seen the service stanza before, where you would define the service stanza on your tasks to register them in console. So In the base, this is the same, only now you can define your service stanza on the group level as well, where you can still define the name and the port and tags, etc. But you can now also specify the connect stanza with the sidecar service. So what this will actually do is it'll tell Nomad to actually inject a sidecar proxy into your task group and then configure it correctly with the service discovery information from Consul. So if we would apply this job, we would now get a sidecar service with our API service and register that proxy in Consul. And if we want to talk to an upstream from the API service, we can then define that upstream. Say, for instance, we want to reach the payment service and we want to reach it on localhost 9091. We can just define that configuration directly inside our Nomad jobs by specifying the proxy and the upstreams. And you can have multiple upstreams per sidecar service. And you can even configure some additional things for that sidecar where you can specify it more to your liking. Say, for instance, we wanted to have the L7 features of the service mesh. We can then set the protocol of this sidecar to HTTP. And say, for instance, we wanted to expose the metrics of this sidecar to Datadog or to a local Grafana. We can then output those statistics of the Envoy sidecar to a certain endpoint. And there's also the possibility to have a Prometheus endpoint that you can then scrape with Prometheus. And if you really want to go crazy and want to do a very specific customization of your sidecar service, you can even override the whole sidecar task if you wanted to, where you can then specify a different driver or a different Docker image. You can then specify everything yourself. So what I now want to do is actually start using this in like a more real life scenario. So let's migrate from a monolithic application to microservices. So we're going to start off on our Nomad cluster where we have two services. One will be like a proxy or load balancer, and then a second one will be a monolithic application, a payments application. And every call that we do will end up at the payments application. So if we call /payments, the monolith will handle it. If we call /currency, the monolith will also handle it. So that's where we're going to start off. And then what we want to do is where we have this payments application that calls the in-process function currency, we want to instead move towards where we have the currency functionality in a microservice. So when we call /payments, we end up at the payments monolith, and if we call /currency, we end up at our little microservice. But we want to do that without editing the web proxy or editing the payments service. Right? We want to first build the functionality and test it. So what we want to do is we want to use the functionality of the service mesh and especially the discovery chain to do this for us by just changing configuration instead of code. So we'll be using the service router, where you can take L7 criteria such as paths, say for instance the /currency path we saw before, we can then route on that. Or if we pass in certain HTTP headers, we might want to route differently to a service. And then we can use a service splitter to split traffic between two subsets of a service or even across different services. And finally, a service resolver where we can define different subsets of a service by specifying criteria that it should match. Say, for instance, we want to split a service into two subsets dependent on the tag they have. Okay, so first, to get the situation that we just sketched, we're going to use the service router, where if we're calling the payment service, but we're specifying the path of / or anything for that matter, we want to end up at the payments monolith. And if we call /currency specifically, we want to end up at the currency microservice. And we want to do this in a safe way where our users are still ending up at the payments monolith, but say for instance, our developers would end up at the microservice. So let's use this. So let's take a look at this code. So I have my currency microservice. we see here that it's using the bridge networking, and we're specifying the service stanza for it. Right, so we're going to register it as currency, and we want a sidecar proxy. And then other than that, we're just using the fake service again, which will just listen on a port and then respond to us with the currency response. So let's first apply this new job, right? So, oh, well, I did one too early, but let's do 4 as well. So we're going to launch the API that will want to talk to the payments. And I've already deployed the currency application, but don't worry, my PAPCAC won't influence this. So now we see that we actually have a lot of services registered. We have our API service with the sidecar. We have the currency microservice that we're going to use later. And we have the payments and its sidecar as well, right? And in here, we have our 3 jobs, the API that we deployed before, but it now has an upstream defined that it wants to talk to the payment service. So if you take a look at the API, we see that we've specified the service stanza, and our sidecar wants to talk to an upstream of payments. And it's only listening on the local port, right? But just so we can show the demo and I can actually curl the endpoint, I've also exposed it on the host. And then if we take a look at payments, we actually see that we've specified the sidecar again, but there's no upstreams defined for the payment service. So the API will actually call the payments. If we look at the application, we see that it will call the upstream URI on localhost 9091. So it's not trying to directly reach the payment service. It'll go through this local proxy that we've defined. And then the payment service will just respond with payments. Okay, so now that we have that running, let's find out what the machine is that the API is running on now. And we can see that it's now listening on .12. So it was moved again. And if we curl that, oh, this always ends up bad. So let me copy paste it from here. And we see that we are calling the API, which has gotten this internal address from the bridge networking, and it is calling the upstream, and it's going to the payment service, which again is a different task group and therefore has a different IP, right? So normally they would not be able to talk to each other, but through the sidecar service, it's actually configured so they can reach each other. And that's why these calls actually work, just by them talking to localhost to the proxy, and that then gets forwarded to the proxy on the other side, and then reaches the other task. Okay, so now we have our currency application, but if I call /currency, it's not working. I'm still ending up at the payment service. So what we want to do is we want to define some configuration of our service mesh that will actually do this for us. So what we're going to do is we're going to create a service router for the payment service. And then if one of the route matches, then we're going to the destination, right? So in this case, if it matches the HTTP header of group dev, so our developer group will want to test the currency application. If they specify that, then they should end up at the currency. So right now, if we specify that header, we still end up at the payment service. But if we do the correct step, if we use console config write and then just write that config file that I just showed you, we now should, if we go to normal currency, still end up at payments. But if we specify our header, we actually end up at our other microservice. And we didn't change any of the code in the API. Just through configuration of the service mesh, we are now intercepting the request to the sidecar proxy and sending it to an entirely other sidecar proxy. So That's cool. Now we know that the currency application works. Now let's start using that. Okay. So let's maybe start doing an A/B test where we create a different version of the payments monolith. So right now we're in this situation where we do have a microservice, but we're not calling it. Payment still calls the in-process currency function. Where we instead want to go is we want to deploy a second version of the payment service that actually calls that microservice. And so we can slowly start breaking off this functionality from this huge monolithic application. But again, since we're a big company and we don't want to lose any money, all our users still should end up at the version 1 of the payment service. And we only want our test group to end up at this V2. So how can we do this? Well, since they're the same service, it'll be difficult to route to them, right? Some users might end up at a different allocation of that service because it'll just round robin over the DNS entries. What we instead want to do is we want to split up that service into 2 versions, but not by actually changing the service stanza itself. We want to create a service resolver where if the service has a tag of V1, we want it to go to the old version. And if it has a service tag of V2, we want it to go to the new one. And then we want to do that routing based on the headers. So if you're in the test group, we want to go to V2. Now we can use the nice functionality that Nomad already has, the Canary release function, to do this for us. So let's see how we can do that. So if we go back to the jobs and we take a look at the payment service, we see here that we had the tags of V1 specified, and we also had some metadata specified, and we had update stanza specified. And this is very important because we enable the Canary release functionality. But we also said that when we release a new version, we want to have a Canary first, but we don't want to automatically promote it if it's healthy, right? Because we first want our test group to test this functionality before we actually start promoting it. We want to do that manually. Now, the V2 version of the payment service is pretty much the same. It just has a different tag for the service stanza. So this is the V2 of that service, but the service is still called payments, right? So it's the actual same service, just different metadata. But what's different is that the payments module now has an upstream to currency, and the application is actually calling that upstream. So let's deploy this new version of the application. So all we're doing is nomad run of that new file. And if we take a look, wrong way, at the UI, we see that we still have payments, but we now have a Canary. And if we wanted to, we could promote that. But what's important is in the console UI, if we look at payments, we now have 2 instances, one with V2 and one with V1, but they're still exactly the same service. Now we want to actually start differentiating between these 2. So here's the tag for V2, and the other one has the tag of V1. So what we want to do now is define that service resolver. And we can do that by creating some configuration again. So we're creating a service resolver for the service payments. If nothing matches, we want it to go to the old version of our application, right? So that's our fallback, V1. If we have the tag of V1 in the tags of our service, we want to go to the subset of V1. Otherwise, we want to go to the subset of V2, right? That's the 2 categories we've specified. Now we can use these subsets in our routing. So let's go here. This looks very much like the router we had before when we were routing to the currency application. But instead, when we are routing to the payment service, if we are in our test group, we want to change the destination to payments, but the subset of V2. And as you can see, I've not specified the V1 subset here anywhere, because if it doesn't match any of these routes, it'll fall back to the default route. And in this case, it'll be the default subset of V1. So that's exactly what we want. So let's apply this configuration. Let's test before that nothing has changed. Shouldn't be localhost. We need to figure out the IP of where it's now running. Let's see, job API, go to the allocation. Okay, still on .12, that's good. And if we call that with curl, we see that we go from API to payments v1, right? So we still end up at the old version. Now, if we actually apply the central configuration with the resolver, if we call this, we still end up at the same application. But if we are in our test group, we still end up at our v1. Let's see. I did something wrong there, and now I'm going to figure out what it was. So that works. Is that configuration applied? Let me double check. See, we have that v1, v2. Okay, let's see. So that looks correct. Let's see the router. Okay, so we didn't apply the router configuration yet. Okay, so that makes sense. Let's write that router as well. Phew, didn't make a mistake. So if we call the normal URL, we end up at payments v1. If we call it from the test group, we can see that we now have an extra long call chain because payments v2 gets called and payments v2 actually calls the currency microservice. Okay, that's very nice because now our normal users can use the old version and we can now actually test the new version ourselves. Okay, so now that we know that the new functionality is working and the microservice version of our payment service works, we are now in this situation where everybody still ends up at the old version, but we want to slowly introduce users to our new version, and not just the test group, like the general population. And then we want to slowly bump that up until it's 100% and we can remove our payments v1. So what we can do is again use the Canary features of Nomad. So we already have that Canary running, and we can use the service resolver we defined before with version 1 and version 2. And if we add a service splitter configuration, we can then slowly divide that traffic over those two versions. So instead of routing on the host path, we can just route all the traffic between those two services depending on the percentage. And we can then, as long as it adds up to 100%, choose any amount of subsets and any amount of percentages. So let's start doing that. So let's take a look at the traffic splitter that we want to apply. So in this case, we create a traffic splitter for payments, and we're just going to split among two subsets. But there could be any number of subsets that we would want to route traffic through. So in this case, we're going to send 50% to v1 and 50% to v2. So let's apply that configuration. Okay. Now, if we would curl the endpoint, we end up at v1. If we curl it again, we go to v2. And as you can see, it's pretty much split between the two. Okay, now we can check our monitoring and see if the metrics and everything's okay. There's no strange log lines, there's no strange metrics, the application seems to be doing fine. So we can now slowly start to bump up that traffic to 100%. So all we're doing is we're changing the value from 50-50 to 0 to v1 and 100 to v2, right? So now if we would actually curl the endpoint, we can see that we always end up at the new version of our application, right? But we're still running both of the versions in our environment. If something would fail, we could always roll back, change the splitting to use only the old version. But now that we actually know that everything's running perfectly, we can actually promote this version to be the new stable version. So we can use the UI to do that, or we could use the Nomad deployment promote command on the command line. And now it'll actually stop the allocation that we no longer need with the old version, and it'll automatically get removed from Consul Service Discovery. So we now only have one instance, and it's only the one with v2. So if then we would create a third version of our application, we would just change the subsets to be v2 and v3, and then we can go through this again without actually having to impact our environment at all. So this makes it really easy to do Canary deployments, A/B testing, just by combining Nomad and Consul functionality. So that was my demo. Let's move to questions. Are you still there, Ed?
Yes, I'm still here. So if anyone has any new questions, we already have a couple that we've received throughout the presentation. So we're probably going to start with some of those, but feel free to ask more questions as we go through the ones that have already come through.
So do you want to read them out and ask them, or?
Sure, I can do that. I think the first question that we have from the audience here is, how is this different from usual bind mounts? I think this was towards like the fairly beginning of the presentation.
Yeah, so what the host volumes gives you is actually you're specifying a volume on a specific host, right? So it's bound to that specific host. And then that actually allows you to also schedule jobs that need that volume. So they'll only be scheduled on a host that actually matches that criteria. So that's actually really nice. It doesn't get scheduled everywhere, and you don't have to specify those constraints yourself anymore.
Great. Other question here. Are volumes just for exec and raw exec drivers? How does this relate to traditional Docker volumes?
So correct me if I'm wrong. Nick is somewhere in the chat as well. So if I'm saying it wrong, it should apply to all of them if I'm correct. But you might still have to map them into the containers yourself. Double checking with Nick. Is that correct?
I think we can go back to this one once like we get a response from Nick. The next question is, if the group has the IP, how do you target a task from inside the group? How do they specify each other inside the group on the flat network? Is it by task name? How does the sidecar proxy know how to talk to the service database in this case?
Okay, so from within the group, it's like talking to localhost. So it's like the concept of pods. A lot of people are already familiar with. It's like a pod where it has an IP on the outside, and then inside it's actually like as if it's talking on localhost. So they have shared networking stack with the same network device.
Okay. Does Nomad support 0.7 CNI plugin version?
Oh, Nick's actually filling this out. So Nomad has only been tested with 0.8.1 plus, he says. So not with the older versions.
Okay. Is it possible to set dynamic ports when the service is at group level? When we create volumes for certain service, if the services is moving around, does the volume get replicated or created where the service is running? Does the data that get replicated, or does the service stick to where the volume is created?
So if you're using the host volumes, then it is actually allocated with that host volume, and the data stays there. So it's not replicated. You would need something like a CSI plugin to actually have like a distributed storage. So it does not do that. But if you, like once the CSI drivers get implemented and you have like an overlay disk, then that could work. And as for the ports, there are actually extra environment variables that get exposed, and I'm looking them up right now to tell you exactly what those are. So you have the Nomad port label and the Nomad host port label. Those variables still get set for the group network ports.
How is the sidecar proxy executed? Does the Envoy binary need to be installed on the node?
Okay, so by default, the sidecar that gets injected actually uses the Docker driver, and so it'll launch the Envoy Docker image. So then you do not have to have the Envoy proxy installed. If you are overriding that task, say for instance, because you do not have Docker driver on those hosts, then yes, you could use an Envoy binary on the path to override that. But by default, it uses the Docker driver and then the Envoy Docker image.
For service router, you are managing console config separately. Are the plans to allow these to be defined within Nomad jobs? This would seem like a much simpler workflow.
Yes, there are ideas of doing that through Nomad, but we have to figure out what the logical configuration for that is. So it actually matches the life cycle of your Nomad jobs, where some configuration might be living longer than that job. Say, for instance, if you have multiple versions of a service, etc., or if you have configuration that is more generic. Say, for instance, the protocol configuration I did on the sidecar proxy, you can actually specify that globally, so all the proxies will actually be of protocol HTTP.
Will the source code from the demo presentation will also be shared?
Yes, I will be putting it in a Git repo, and I will be sharing that. So we can send that out with the email with the answers to the questions.
Awesome. Will CNI be included in upcoming releases, or will we just need to make sure it is on every client?
So right now, it needs to be installed on every client. I believe Nick actually had it working where it would automatically download the CNI drivers or plugins themselves. I don't know if that made it into 0.10, so we're going to verify with Nick for that.
How does dynamic port mapping work with these stanzas? The examples seem to show static mapping.
So if you have these sidecar services, like normally to make sure that all the applications or services could get deployed on one host, you would use dynamic port mapping, so you wouldn't have any port clashes because they're unique resources. But because all of the allocations now would get its own IP address, there's no clash there anymore. And the only port you're actually specifying is the port that you want the sidecar proxy to listen on localhost inside that allocation. So you would not need to use the dynamic ports anymore, but you could still use those and define them.
At some point during your demo, you specified a rule to route to V2 if the test HTTP header was specified. Anything that didn't match would go to v1. Is there a way to link the latest promoted version instead of a specific tag?
So I actually had that set up before by using the functionality that Nomad has inside, which is the Canary tags. But for the flow of actually releasing, that wasn't directly useful, because after it gets promoted, it'll actually remove that tag. So then you would have to then apply the service splitting again, or delete the configuration to actually make it route to the version without the tag. So yes, you could do it automatically by saying, I want to route to the Canary tag. That does work. But for the next step in the actual migration, you then have to do a lot of manual work.
If the client doesn't have Docker driver, will it stand up a sidecar with the Envoy binary?
Could you repeat that?
Yes. If the client doesn't have Docker driver, will it stand up a sidecar with the Envoy binary?
So if you specify the sidecar override, let me actually show my screen and then show you that. So if we go to sidecar service, you have the sidecar service there, but you can also use the sidecar task, where you can then override any of the fields. So you can override, say for instance, the driver. You could change this to exec, and then you could just call the command envoy on the path. That would work. You could even call the built-in proxy that Connect has, if you were able to use Envoy right now, say for instance on Windows.
Does Nomad support mixed network mode? For example, console running in host while task running in bridge networks.
So that would then be different job groups, because they would have the different networks specified.
What would be a good practice to have version change v1, v2, v3 if the deploy would happen with a CI/CD?
So then you would want to put this configuration, say for instance, the routing and splitting, you would want to put that in your CI/CD so it actually gets applied by CI/CD. Because basically you're updating the deployment file and you're updating the configuration that applies to that specific application. So I would then basically call either console config write with that configuration that's located in my application repo, or you could apply that configuration with Terraform provider as well, and do it that way.
Okay, I think we have time for like maybe one or two last questions. So the next one is, what about non-static IP with new bridge network? Will it work? Could we point only target and have dynamic source, sorry.
Trying to figure out what he exactly means. So let's see, what about non-static IP with new bridge network? So that's basically using the network mode equals bridge. That's kind of what I'm assuming. So I don't know exactly how to answer that, because I don't understand the question exactly.
Yeah, if whoever asked that question could like follow up with like more details, we can definitely try to get that answered maybe over email after as well. I think actually that was the last question that we have. Yeah, I think that's it. I want to thank everyone who submitted questions, and thank you, Eric, for taking the time and answering all of those as well. I hope everyone enjoyed today's webinar and have a better understanding of Nomad 0.10. If you want to check out the other webinars that we have coming up, you can do that at hashicorp.com/events. And like I mentioned at the beginning, I just wanted to remind everyone that the webinar was recorded. So we will be making the slides, the recording, the answers to these questions, and the code available to you in a couple of days. And I'll send that over email with the pertinent links. Thank you so much and have a great day, everyone.